Good afternoon and welcome back to AIEC Webinar Weeks. AIEC's Webinar Weeks aims to address today's industry challenges and opportunities along with solutions and tips on how to overcome them. It's hard to believe this is our 32nd webinar since what, November?
Yeah, beginning of
So
November.
yeah, it's been fun, and we're looking to start back up again in March 2nd to be exact. So look forward to that. Also, within, I'd say, the next week or so, hopefully tomorrow, we'll have a survey out to you. Please take a moment to fill that out. Love to hear your feedback. And that'll also get you into a prize drawing that we will have at our first webinar in March. So please be on the lookout for that. Also, our CTC conference is set to happen at this time in person in Bloomington Normal on October 13th through 15th. So we look forward to seeing you in Bloomington, you know, if we're able to have that. So right now that's our goal, and we're sticking to it. So we'll see how that goes. Our presentation today will last roughly 40-45 minutes. We'll leave 10 or 15 minutes towards the end for Q&A. As always, please submit your questions to us through the chat function. Use a little drop-down box and select AIEC. That'll direct those questions to Brian and myself, and we'll moderate those questions to our presenter on your behalf. With that, I think I'll turn it over to you, Brian.
All right, just a quick reminder, this session does qualify for PDHs, so I'm pretty sure I have a record of all the people that had signed up. So I'm hoping to get those certificates out for the second round of webinars, hopefully later this week. So be on the lookout for those in your email. Our presenter today is Martin Garza. He's been a field service technician for 4 years at Acuity Brands Lighting in the warranty post-sales division in the Texas Southwest region. His duties and responsibilities include product troubleshooting and warranty investigation in the field, along with high mast lighting system installation consultations. So with that, I'll hand it over to you, Martin.
All right. Hello, everybody. I hope everyone's doing well. Like I said, my name is Martin Garza. I'm going to be presenting this PowerPoint for everyone. And at the end, we'll have a physical demonstration, some quick troubleshooting, and pointing out components in one of our light fixtures. All right, we're going to get started. All right, this is our Acuity Brands logo. So the purpose of this training is to get you guys a basic level of understanding for fixture inspections and troubleshooting. Something you guys can do out in the field. If you're out, you get a phone call, hey, one of our lights is out. Something you can just go check out real quick before you start giving our warranty team a call. Maybe it's something small that you can handle there. All right, so during this presentation, we're going to be going over tools and personal protective equipment, the definitions and basics of LEDs, what components and configurations are in a Luminaire, cause and effect of component failures, systems and component failure troubleshooting. And below that are some examples of what you might see out in the field. So non-operational fixtures, erratic operations of fixtures, and then partial operation. All right, so some of the tools and PPE you should have out on the field, or that I'm going to be using today, is a hot stick, multimeter, screwdrivers and nut drivers, and of course gloves and safety glasses. Okay, we'll go over some of these LED definitions and some of the basics. So LED stands for light emitting diode. It's a semiconductor that emits light when voltage is applied to it. What you want to be careful with is the third basic down here on this screen is handling LEDs. You don't want to directly touch any light emitting diode. You could damage it or cause issues with the solder joints. some more basics. All LEDs have heat sinks in them. All heat sinks need to, oh, sorry, I'm on the wrong screen here. We'll go down to power requirements. LEDs are energized via DC voltage and current. This is typically supplied by a driver which converts a higher AC voltage to a lower DC voltage. The driver output and LED performance are integrally designed. Thus, using the correct driver and LED combination is necessary. So that's one point that you guys can check out in the field when you have a non-working or non-functioning light fixture. You'll open it up and just verify that you do have the correct DC voltage going to the LEDs. So we have different types of light engines in our fixtures. LED strips, adhesive strips, linear boards, non-linear boards, or COBs, which stands for chip on board. Mostly what you guys would see out in the field are the non-linear LED boards and chip on board arrays, which are these here on the bottom left picture. Those are the COBs. So what components and configurations are in a Luminaire? So this is kind of a drawn out matrix of different components that you can have inside of a fixture. It can go anywhere from just straight line power to a driver to an LED board. Then you can get more complicated once you get down towards the bottom, adding surge protectors and sensors and controllers and different options. It all depends on what is ordered for that site. So here's kind of a breakdown of one of the light fixtures that we have. And this is basically what you guys would see out in the field. You have an LED driver, the light engine, DCM stands for Demi Control Module, which will not be in every fixture, just depending on what is ordered. Your 3-position terminal block and some type of surge protection device. Here's an example of one of the drivers used in our fixtures. The purpose of the driver is to convert the AC voltage to a lower forward DC voltage that actually illuminates the light engine. Typically rated for 120, 277. Some have 480 and they can be M volt. If you take a look at the label on these drivers, it'll actually give you all the information, all the ratings for that specific driver. Other drivers have other labels and stickers on them that will show what that specific driver is programmed to. And I'll be able to show you that later in a physical presentation. Okay, another component would be a photocell. These photocells are what detect ambient light source, and these tell the fixtures whether it be on or off. They're normally twist lock, NEMA connectors, and they're not always required to have in a fixture. You could have a shorting cap on that light fixture, which would keep the light on. This is definitely one of the first things you want to look at when troubleshooting. You can see the little NEMA, the little connectors here. If they're not locked on all the time, sometimes you'll get a non-operational fixture. I have been out in the field before, and a row of street lights that were told that, hey, these aren't turning on. And I've definitely gone up on a lift and gone to the lights and just said, hey, your photocells aren't on. They're not on all the way or not twisted on all the way. So stuff like that, little things that you can check just to make sure before we take a flight out there and take a look at these fixtures. Here you got a terminal block. You guys should be very familiar with these. 3-position hot neutral ground, secured with barrel nuts. One thing that I do run into on the field is these are over tightened, probably with an impact or something, and they break these barrel nuts off, which make it real difficult to start troubleshooting, or if you didn't get a good connection on your source voltage. Surge protectors, those are also present in these fixtures. There are many different types and styles. They're meant to protect the fixture from power surges or spikes. Ratings can be labeled on these surge protectors or not, and there's different styles. So if you look here onto the right, this is a little fuse surge protector, and these are actually pretty nice because once you open them up, you don't need to start taking voltage readings right away. You have a little indicator light here that'll tell you if the surge protector is actually tripped or not. Some other ones, they don't have that, and you do have to start taking some voltage readings just to verify if the surge protector is still good. We have field adjustable output modules or dimming control modules. These are used in light fixtures that have dimming control. Not all of them do. This is where your violet and gray dimming control wires would be attached. So we already went through the different types of light engines or LEDs. So we have different types of fixtures. We have external fixtures that we service. They're mostly watertight, and these are the different types that we have: industrial, commercial, and then we have specialty light fixtures that can get real complicated. You guys are mostly concentrated here in our external fixtures, street lights and things of that nature. Okay, we're going to move on to the troubleshooting section. So these are the type of fault types that you can see out in the field. You always want to take caution though and practice electrical safety when troubleshooting. You do have to remember that when you are going up to a fixture that's acting erratic or out, you could be coming in contact with voltage because that fixture is not in a normal or working state. So you just have to be ready for anything. So these are the type of faults. Non-operational fixture, it's not responding to any commands or not coming on at all. Erratic operation, blinking, flickering, turning on and off. One of the main questions I will ask if I get a phone call about erratic operation, is it one or more fixtures that's doing this, and are they acting in unison or are they sporadic? You can have dim light level outputs and partial operations. So if you have a light fixture that has a board or multiple groups of LEDs, you'll have portions of those LEDs that are out or dim. Okay, we'll go over a non-operational fixture or out. So some of the things you are wanting to check when you're troubleshooting, you want to check the components and all the wire connections. Verify all your wires are good, no copper showing. Is there a photocell present? If there is said photocell operational? Like I said before, verify that the photocell is on tight and connected correctly. You can even pull it off. Verify there's no corrosion or anything on the pins. One thing would be helpful is to always have at least a known working photocell on you or in your truck. That way you can take up to a fixture. That way you can at least rule that out. Is there any visible damage to any of the fixture components? So as soon as you open that fixture, I mean, is there any acrid odor, any visual burn marks from any of the components? Normally, if you are going to see anything, it would probably be located there at the SPD or surge protector. You also want to check your wiring. all your wiring joints and connectors. Let me see if I can't get back to my screen. All right, am I back?
You may need to
Can you see?
share your camera there, Martin.
All right. Okay. So in our fixtures, when we use wire connections, we use these lever type Wagos. Older Wagos we used to use that you guys could still come into contact with are these gray Wagos here. They have a test port on top, so you don't have to open any doors or anything to take voltage readings. You can stick your probes right into them. Now we're moving over to these newer type lever Wagos, and these test ports are right here in the middle. They're right here. It's just a lot safer for you guys to do that rather than trying to break any connections or accessing live wires. Okay. So once you verify all your connections and wires are good, you want to move down to your source voltage. You always want to check to make sure that you have the correct voltage to that correct fixture. So is there power to the fixture? A voltage detecting stick will assist you in loading, letting you know if voltage is present in the fixture. Note, however, it is always best to verify the incoming voltage with a meter. I know you guys are probably used to voltage detecting sticks and how they can be a little iffy, but it's just always good to re-verify with the meter. Power verification for the components. So does the correct source voltage match the fixture rating? When you open these fixtures, we always have labeled what type of fixture and their voltage rating on the fixture. So you just want to verify that you do have the correct voltage to that fixture and to all the components. So like I said earlier, LED drivers require a higher AC voltage to convert to a lower DC voltage. And you want to make sure that lower DC voltage coming out of that driver is within the parameters for the said LEDs. Troubleshooting from here may be necessary to have wiring diagrams and possible spare parts for replacement of fixture components. And that's really what you always want to have is, like I said, the photocell and SPDs or surge protectors, because that's probably where you'll see your issues. So real quick, some of the steps that you'll go when looking at a non-operational out fixture. You want to verify the functionality of the shorting cap or photocell. Verify source AC voltage. Verify correct voltage is throughout the fixture components. AC voltage, like I said, to the driver, and then DC voltage from the driver to the LEDs. And check for damage or debris or water intrusion at the LEDs. So some examples of erratic operations, flashing or rhythmic or random sequence in unison with other fixtures or independently. So you can start troubleshooting those by kind of like the other one. You're going to check the power to the fixture, make sure that it's the correct voltage for that fixture. I have seen where a 480 driver was in a fixture, or sorry, was in a spot that had 277 as the source voltage, and the fixture did work, but for some reason it caused the driver and the LEDs to have an erratic operation. So sometimes it would come on, turn off, and it would be random just because the driver was underpowered. Internal wiring, you want to access the de-energized fixture and verify that the component wiring is correct per the wiring diagram. Inspect that the fixture is properly grounded and there are no damaged wires. Exposed copper or pinch wires can cause a short in the fixture, and that can definitely get you some odd light outputs. So light engine, you want to verify your components are not damaged or exposed to the elements. Another quick story, I went out to another city of job site, and they were complaining that all of their fixtures had water in them. All of the light engines and lenses had water in them, and that it was damaging all the fixtures. Well, I went back to their storage facility where they had all their light fixtures before they went out into the field, and a lot of them they had stored upside down. These fixtures are water resistant. That doesn't mean waterproof. So these fixtures being upside down out in the elements, they started collecting water on the housing of the fixtures, and that water was seeping into the light engines. Okay, so this is some examples of partial operation fixtures. The causes for partial operation fixtures are typically from the driver for LED groups or individual light engine issues. Okay, so what that means is this fixture here on the left, you can see that there's two groups of 3 each. Well, in this light fixture, there's 2 drivers, one powering one of these groups and one powering the other group. And obviously, just looking at that fixture, you can tell that you probably have an issue with the driver. Same thing with the middle fixture. You can see that there's 2 separate groups. One group is out. So the middle 4 illuminated diodes are powered by one driver, and the outside 1, 2, 3, 4, 8 diodes are powered by another driver. And then on the far right, this would be an example of an individual cob. You can see the cob here at the bottom, and you can see the solder joint was broken between the light engine and the driver. That can also cause an erratic operation if that joint there is barely making contact or not making contact, and for some reason it's rattling. Those can get shook loose, which would give you a weird erratic look. Okay, so here's some examples of partial operation, kind of a better way to look at it, maybe an easier way. So you can see here to the far left, this example, you have 8 LED or light engines, and you can see in the middle, the top D1, that's a driver, and then D2. So the D1 is powering the 4 light emitting diodes here in the middle, and D2 is powering the outside. Looking at this one, everything is working correctly. The one directly to the right of it, you can see that your 4 inside boards are not illuminated. So that probably means that your driver 1, D1, is not working. A way to check that would be just to disconnect from D2 down here and attach them to these middle LEDs, just to verify that your LEDs are working. Same thing for the third picture here, just the opposite. So your D1 is working, D2 is not working. The one on the far right, this is showing individual LEDs that are having issues. You can see that D1, the driver is working. It's able to illuminate these LEDs, but you have some type of issue here at this board. Now for D2 on the outside, you can see you're having issues with individual diodes in this LED board. You can run into a situation where you have a dimmer than what you expect light output. Now there's different situations that can cause this. So your driver milliamp output could be incorrect. That can come from either damage to the driver or just the wrong driver altogether, or the driver was programmed incorrectly. You can see down in here in this picture, like we went over before, this light fixture here has two drivers, one power in this group, one power in this group, and this one is obviously not working correctly. So for that, you want to verify your DC output coming out of those drivers and just verifying that both of them would be the same. All righty. Any questions?
Questions at this time, Mark?
No? Okay. All right, so the next section, we're going to be going on to the hands-on troubleshooting. Like I said before, whenever you're out in the field and you're going up to a fixture, you just want to make sure you're taking all your safety precautions because you are about to access a fixture that is not in its normal state. All right. All right, can you guys see me on the full screen?
We can, yes, it looks good.
Okay. All right, so like I said, some of the tools and PPE you'll need, gloves, voltage detecting stick, wire strippers, screwdriver, nut driver. You can use an impact, but I would be very careful. I've gone to a lot of fixtures where guys just wrench down on that impact and they'll break screws off into those into the machine heads, or break machine heads off. Multimeter, safety glasses, flashlight. All right. So the fixture we're going to be looking at today is an Autobahn, one of our ATB Autobahn fixtures. I was able to procure this fixture from one of our distribution centers. Now this fixture is working. I tested it before. It has no damaged components in it, but we are going to go through the steps and we're going to check this fixture out. Okay, so I don't know if you guys have seen or worked with these type of fixtures, but all of the basics are the same in these. They could be a little more complicated depending on how many light engines are actually in the fixture. But this is just a basic one cob Autobahn fixture. You have your photocell. I have temporary power to it now. This is a 120/277 M volt fixture. Here at my house, I have 120, so that's what we're going to use today. All right, so we're going to go over the scenario. Apply power. Okay, so I just applied power to this fixture, and as you can see, nothing's on. Photo cell's intact. So what you would do first, you'd walk up to this, you'd go up to the lift to this fixture and just verify your photo cell is on tight. You can also disconnect it, take it off, and just verify there's no corrosion where you would have water or debris getting into your Neiman connector. All right. See that. Okay, so now we have the bottom of this light fixture. So here we have our glass lens. You have your access screws here that accesses this plate where you can get to this light engine. The other screws and mounts here are for other options that are available on here. You have a wing nut. So you don't even need any tools to access the internals of this fixture. Everything on this is loose though, just for sake of time and demonstration. So this is the inside of one of our ATB Autobahn fixtures. Like I said earlier, here you have a wiring diagram that's attached to the door of the fixture. You have the description of what this fixture should be. Power rating, let me see. You have your power rating 120, 277 volt. It has your watts rating when this fixture was put together and a description of the name. You also have your warning sticker here. All right, so knowing that there's power to this light fixture, but no light is on, I know we're in some kind of degraded state. So you want to just verify your input power. Okay, there is something there. So next thing we can do, we're going to verify at the terminal block that we do have the correct voltage. Okay. So I had a loose plug. So you guys can see there's 125.2 volts there at the terminal block. So then you're just going to start moving downstream. Your very next inspection you want to look at would be this surge protector here. You can visually look at it and see there's no damage around it. There's no burnt wires, no physical discrepancies on it. So you can just follow your wiring diagram and verify you have your same source voltage coming in and out of that. If I can get it. Sorry, I'm doing this backwards. I'm looking at you guys. Sometimes it's a little easier to get some of these leads, smaller leads, attach them to your multimeter. It's easier to get in there. Like you guys can see here that I'm not disconnecting any wire nuts or anything like that. I'm just right here in these test ports. I'm getting 125 volts. Okay, so now I know my surge protector is good. I know I'm getting voltage to my terminal block. Now what I need to check is that power is getting to and from the photocell. So you could check here. Just follow your wiring diagram. I'm getting 125 there. And that voltage check also verifies that you're getting 125 volts to your driver. What I'm going to do is I'm going to disconnect power because I want to show you guys the driver. So power is disconnected. So on some of these drivers, the label is always on the top, but the driver could be installed upside down. So looking at this here, this is a label that shows the individual programming for this driver. There's your leveling bubble that we provide, and just going to use my 5/16 nut driver. This is for a little bit of further investigation if you want to just make sure that you have the right DC voltage coming out of this driver. Make sure you're within range and parameters. So this comes out just like this. And just like the picture that I showed you guys during the PowerPoint, all of your information is going to be up here on this driver. So you can look down here and you can look at your parameters for your voltage, your DC voltage that's supposed to be coming out of this driver. It also tells you what each wire is for basic stuff. There's your 120/277 M volt rating. This is a Philips Advanced driver. Get a good look at that. There's different types. You won't always see this driver, just depending on what is ordered for that specific light fixture. Here's your purple or your violet and gray for your dimming volt or your dimming circuit. This fixture does not have that. Let's attach this back real quick. And apply power again. Okay, let's power back at this fixture. Okay, so we've verified that we have incoming power through our terminal block, through our surge protector. Our photocell has voltage coming through it and all the way to the driver. Okay, so right now our light is not on. We can narrow this down to either the light engine or some type of wiring issue. So what we can do is we can take our meter. You got to remember, switch this to DC voltage because now we're checking light engine voltage. Get within range. Take your two test ports here, red and blue, goes to your light engine. Okay. Now I have voltage here, but I have no light coming on. It tells me my driver is good. but something is going on between this this light engine and the driver. Before I start taking all this apart, I want to verify that these connectors are correct. Disconnect power, just to be safe. I don't want to go viral. So you can disconnect your Wagos and just verify you'll see a mark on your copper. Just verify you're getting a good bite. You guys see that pretty well. So from your driver, looks good, you're getting a bite. Okay, so this would be your issue here. I don't know if you can see, but there's no copper coming out of the end of this wire. Not necessarily saying this is a problem. This is just a safe issue that I could replicate here. This falls under checking your wiring and checking your connections just to make sure everything's good. So what we're going to do is take another bite out of that. Power is disconnected right now. Okay, make sure our connections are tight. We can reapply power. You guys can see that it lit up. So something as simple as a Wago or wire nut not getting a good connection can stop the light from coming on. And those are the basic components. I mean, if you start getting any further than that, you should probably start getting post-sales or warranty involved. What we're going to do is I'm going to open this up just to show you guys the watertight capabilities of these fixtures. So what I was saying when I went to another city and they were complaining about water and damage in their fixtures. And I went and looked at their storage facility. Well, they had lights just like this, all hanging out. And just, you had a water line probably up here. Like I said, these are water resistant, but not waterproof. I'll show you guys what I'm talking about. Once you start getting this far though, I wouldn't recommend you start getting close to the light engines because they're very sensitive once you start getting on the LEDs, and if you start touching them, you could break solders, you could damage the diode itself. Some of them have color coatings on them that you could damage. But I'll go ahead and show you so you don't have to. Okay, there's your plate, your mounting plate. And on the inside here, we have a rubber gasket that goes around our glass lens. And your blue and red DC volt wires that come from the driver actually go inside the gasket. So there should not be any wires below or on top of that gasket. They're pretty tight. Just want to be careful if you start messing with these, that you don't break any solder joints. Because once you break that, that's not field replaceable, and you have to get a whole new fixture. But you can see there, that's what one of the cobs looks like, and that's how tight our watertight seal is. When you're looking for damage on those, if you've gone through everything and you're just like, I know it's at that LED or it's on that cob, what you're looking for is any kind of discoloration on the LEDs themselves. You want to look for You want to look for any burn marks around that cob, and solder joints. Just make sure nothing's broken and everything's in working order. You could even take a voltage reading. If you really wanted to, you could take a voltage reading right there at that COB. So, well, that is a basic. That is a basic Autobahn fixture. Pretty popular fixture, either in the in that one cob group or the 3 cob group. All right, I think. Let's see. Do we have any questions?
No questions at this time. Martin, we'll go ahead and give them a few minutes here. If they'd like to, if they have any questions, you can go ahead and enter those in the chat feature in Zoom. Go ahead and select a drop down and send those to AIEC. Martin, while we're waiting for some questions to come in, first of all, I want to say, that was a great demonstration. I think I speak for everyone when I say that was very informative. If someone would like to reach out to you, what is your contact information?
Okay, so yeah, you can reach out to me via email, Martin, MARTIN, .Garza, GARZA, @acuitybrands.com. I'll even give out my work cell, 678-689-4406. I'm in the central time zone, so if anyone has any questions while they're out in the field, it's easy to give me a call, shoot me a text or an email, and I'd be able to help you out. I'm not tech support, so you might get directed to tech support, but sometimes it's easier if if you're out there, give me a quick call, and I'd be able to definitely be able to walk you through some stuff. And I'm available.
Well, we still don't have any questions, which is usually a pretty good indicator that you did a good job of explaining everything. So we'll
Thank you.
We'll accept that. No, very good job, Martin. Again, thank you very much. I think that was very informative. We appreciate your time today for sure, and hopefully we look forward to some times when maybe we're able to meet in person.
Yeah. Yep. Yeah, that's for sure. When all this is over, maybe we can do that again. I have given a class before in person, and that's always just a lot better when guys can get a hands on, raise their hand, questions, a little bit better.
Sounds good. Well, again, thank you very much. So this is going to conclude our final webinar in Series 2. Look forward to Series 3 of AIEC Webinar Weeks coming up on March 2nd. Be on the lookout for an agenda for that. Also be on the lookout within the next week or so, maybe even tomorrow, from Ashley. Look for a survey. If you would please take some time and fill out that survey. That'll get you entered into our drawing that we'll have on our first webinar on March 2nd for our grand prize giveaway. Just to say thank you. We appreciate you supporting this program, and we hope we've been able to provide good content to you, informational, and again, we're looking to provide solutions, not just products. So that's the whole goal of AIEC Webinar Weeks. Brian, you have anything to add?
No, just thanks to everybody for participating, and be on the lookout for those PDHs. Hopefully later this week, I'll be sending those out. So just be looking for an email from me.
All right. Well, again, thank you very much, everyone. And that concludes our final webinar in Series 2.
Thanks, Martin.
All right. Thanks, guys. Take care.
You too.